Welcome to the Harvesting Wisdom podcast. Together we explore the vast landscapes of life, delving into the rich soil of experiences, sowing the seeds of curiosity, and harvesting the profound wisdom that each episode unfolds. Hello and welcome. This is another podcast episode of Harvesting Wisdom. My guest today is Peter Ellsworth. Peter is a full specialist and professor with the University of Arizona, Department of Entomology. Bugs. You're a bug guy?
Yep.
And the IPM coordinator and director, Arizona Pest Management Center, stationed out of the Maricopa Agriculture Center in Maricopa, Arizona. Leveraging applied insect ecology to develop sustainable and economically viable pest management strategies focused on science-based IPM solutions and ecological investigations, targeting key pests like Bernesia tabaci. Thank you.
Yeah.
Lygus hesperus.
Hesperus. Yeah.
Hesperus and
Oh, you're not going to get that one.
Pectinophora.
Just say pink bollworm.
Pink bollworm. Okay.
And every cotton grower in the state will know what you're talking
Everybody's
about.
got it. That threaten the cotton ecosystem, and other crops using a predictive approach to pest management, including insect phenology and predictive modeling, aiming to create a balanced ecosystem that aligns pest management with economic and ecological sustainability under the guidance of the Arizona Pest Management Center's director. Managing the NIF extension IPM grant and coordinating statewide IPM pesticide regulation efforts while leading in the multidisciplinary team of researchers and extension faculty, driving in the advancement of IPM science and practices to protect agricultural assets, ensure ecological balance, provide smart strategic solutions for the benefit of farmers, consumers, and the planet. So that's a lot to say.
It is.
But it's kind of easy to understand. Everything's interdisciplinary. That's industrial science took us in that direction. And so really the key is the communication, right? And the being able to work with other people who specialize in these different things so that you're not going in any one particular direction. But and you and I have talked about, and I mean, this just opens up so many pathways for discussion.
Absolutely.
And we I think the last time we were talking about genetically modified stuff. And yesterday I was down at U of A talking with a professor from Purdue, been around a long time, just an amazing guy and a team of people that he knows at U of A. And the same thing, one of them is an entomologist, the other are geneticists, and he talked about HI and all kinds of different products. You get CRISPR and all these things. Technical terms, some people know when they're listening,
Right.
some don't. But the idea is that science does have a place in a lot of this process. And, if we continue to, everything has to be economical for the farmer and for the consumer. Nobody wants to pay a fortune for, a potato or for whatever that we have out
Right.
there. So in order to do it, though, there's pressures on that farmer, right? And that one of the pressures could be weed, could be a fungus, it could be insects. And so how do you treat that? And there's this whole age-old battle between, not age-old, it's only been around for a while, but industrial farming versus organic, natural pathways versus, but if you're a farmer and you got a crop out there that's like your life savings is in there and you got a bug, you want to quietly kill that bug off, right? I mean, that's kind of the thing. So with GMOs, there's arguments in any direction, but with GMOs, the plants are more resistant and they can handle, so one of the things you're talking about here is that for cotton, for instance, and there's a genetically modified cottonseed too, but there's still pests that have to be treated with and that kind of thing. So
Yep.
I just brought up a whole bunch of things, and I'm going to kind of open that discussion for you. You know, where do you start? Where do you stop?
Well, I think
let's begin with that.
part of it is you start with IPM because, people know the word sustainability. They know about organic agriculture or think they do. They see it in the supermarket. But IPM is a less familiar term, even though it's been around for more than 60 years. So it's integrated pest management. Even in its name, that should tell you something. It's integrated, as you say, it's interdisciplinary. We like to say it's transdisciplinary. And most of all, it's the science-based methodology and for developing solutions to our pest management problems in any environment. So regardless of the brand of agriculture you subscribe to, whether, as you say, industrial or corporate farming or small farm, family
Or
farm,
alternative farming,
organic, sustainable, every one of those needs an IPM program.
Sure.
It's independent of the actual other inputs perhaps that go into.
It's having a plan.
Production.
Every farmer needs a plan.
It's about having a plan, having a strategy, and the science of IPM and the reason why I'm in it is exciting because it's about putting science into practice, directly into practice. I think we need specialists. We need people who really develop the very individualistic tools and the science that support them. But then there's a whole cadre of scientists that have to be experienced in applying those and integrating them together. So if you have a plan for controlling that fungus, it needs to be compatible with that plan for controlling the weed and the insect and the other thing. Mm-hmm. And you say a farmer may wish to, who's plagued by an insect, just might want to see it dead. Well, integrated pest management takes a more holistic view, and it may involve a specific chemical control that will result in the death of that pest, but it also may involve the incorporation of cultural tactics, biological tactics, or other things that might not outright kill the animal, but may disable it from causing the damage that really harms, gives economic harm.
We're having another predator
certainly
come in and do the job for you in a biological way, right? So
right.
But so how long have you been doing this? How did you get a start on this, and what takes somebody, because we do STEM gardens, right? That's for our our nonprofit does these. Now we call them STEAM because we added the arts are an important thing. But how do you get kids interested in something like that? How did your path take you there?
Yeah, well, I don't know if it's of great interest to your listeners, but I started out as a little kid, so I'm a little bit on the unusual side as entomologists go. Many entomologists, professional entomologists, don't discover their passion for insects until very late in maybe their undergraduate program. They finally take a course and suddenly say, oh my gosh, insects rule the world. I need to know more about them, and they go into graduate studies. So they usually get into it later in their educational life.
Sure.
For me, I was a little kid running around in gardens, in fact, with the butterfly net, trying to catch the butterflies and look at them and study them and rear them from a very, very young age. For me, it was an avocation. I never saw it as something that I would ever make a living doing until I finally went to college and realized, you can actually major in this science, and I did that as an undergraduate, which is unusual. So all three of my degrees, my undergraduate and my 2 graduate degrees, are all in entomology, and that's how I got there. But we grew up in a different time. You didn't have access to resources like we do today.
True.
You get on the internet and you can travel the world. Back then, it was just what you knew in the neighborhood.
Where did you grow up?
I grew up in Massachusetts, right on the Connecticut border in the Connecticut River Valley in western Massachusetts.
Yeah. Where my mother's from and my brother still lives.
Ah, great. Yeah.
There's a lot of bugs in that.
Yes, I enjoyed it, yeah.
So when we talk insects that do damage, are we talking mostly arthropods? Is that the category? Arthropods, yeah, okay.
Yep, or insects and their relatives, we generically refer to them as arthropods, but they're the ones that are doing the damage. There are estimates worldwide that really range quite a bit, but they take a big bite out of what we do, despite our good management programs. So it's something we have to be very vigilant about, and I think more deliberative and more proactive about. So one has to really think ahead of time. You don't want to wake up one day and say, there's a bug in my field, what do I do? You want to have a plan before that even happens.
So part of it being integrated,
Integrated, yeah.
integrated. Having a hard time with words today. The part of that is that there's other things being sprayed too, or the other factors, right? So fungus is not a bug, but it can kill a crop.
Yep.
And weeds, can also, destroy your crop or take over a crop. So there's things being sprayed, but if you spray the weeds, you might, there's that butterfly effect, right?
Yeah,
there's that other.
that's exactly right.
So that's the.
Yeah, a weed could be harboring an otherwise innocuous insect and keeping it off of your crop plant. And by spraying the weeds out, you might be forcing them onto your crop plant. So there's all kinds of interactions that you really need to be aware of. And farming nowadays is really about science. And if you're not educated about those things, you need to have people surrounding you who are. And because it's very technical discipline nowadays.
Sure.
It's not just, I like to grow plants. You want to grow plants that'll thrive and provide you your economic livelihood, but not harm the planet at the same time.
So it really is a holistic approach. But so how does it start when the extension services, like, one of the greatest things that we've come up with, and I think they have extension services in a lot of the industrialized countries on the planet, right? And it's the idea of bridging that science and the farmers who are the practitioners with that knowledge base. And I know, even as a landscaper, we knew everything until we didn't, and then we'd call the extension service and say, what's going on here?
Right.
Borers in the native trees and things like that, and how do we treat this? And so it's near impossible for you to canvass all the farms. Do you, when you're working with farmers, are you going out into the field and collecting? Because you would want to collect all these arthropods.
Yeah.
And you would want to collect whatever you could see there to see that ecosystem that's going on before you make a determination on what to do, right?
Absolutely. And that's the focus of my research. I have a research appointment and an appointment in cooperative extension. So I'm very much grounded in the near term in supporting growers that are growing today, not a solution that's decades away. But what we do is what we call applied insect ecology, and it's really about studying the distribution and abundance of these arthropods in these fields, because there are many things that live, for instance, in the average cotton field. We can take kids out and you can look in a cotton field. You might see a half dozen or more species just looking around, but we know through our surveys that there's over 800 different species that live in an average cotton field in Arizona. Well, by far, most of those are innocuous. By far, most of those are supporting the environment in other ways, whether they're detritivores, breaking down the byproducts of your production and returning them to the soil. Many of them are pollinators. Many of them are predators. They're beneficial arthropods. They're the beetles and flies and other things that contribute to the natural control that a grower really needs to depend on in his cotton field. And through many years of research, we've found that there are many beneficial species in a cotton field, and it's about quantifying it in a way that a cotton grower can actually make use of the information and make decisions not to spray when there's enough biological control.
And that's just one commodity. I mean,
that's just one commodity. You have to be aware of everything else. That a farm is not just one commodity. It's a whole ecosystem.
And even a plot is not a farm because it's in rotation. It's one crop after another. So do you get into crop rotation discussions with farmers to say, start with this one, do this one, and let this skip a season with this because you're getting a fungus or something? Is that part of the process too?
Certainly, when you're talking about soil-borne diseases or nematodes, which live in the soil, rotation is a key control tactic, a cultural tactic that we would advise all growers to
Cultural
observe.
tactic. That's
Cultural
the term for
tactic,
it,
yeah. That rotation is key to giving that soil a rest, giving it an opportunity to recover from a buildup of inoculum, whether it's a fungus or some other disease, or planting a host that's not favorable to the nematodes that might attack the
So now
crop.
there's so many different environments and microenvironments in just Maricopa County, and then you go statewide, then you go national, then you go international. Some of these things, we live in a holistic world, right? The wind blows, and it's kind of crazy how I think prior to the Cavendish banana, there was I can't remember the species, but it got wiped out fast. I grew up in the East Coast, kind of in the Buffalo area, and we had Dutch elm disease.
Yes.
And we had the most beautiful 100-foot tall, monstrous trees. And in my childhood, it was wiped out, So
Right.
you see these things coming, and that's part of why we have a Department of Agriculture and why they tell people don't bring plants and animals and things
Right.
in your suitcase. Don't smuggle them.
Right.
Even seeds, right?
Certainly.
And that's
soil.
Yeah, or soil, right? So that's the reason is because it's just you never know what's happening. But how do you stay connected? Because there's no way you can canvas much more than a specific area. So what's your area that you stay in? But then how do you stay connected with all the other people in the department?
Right.
How does that work? Because
Well, we do it virtually through a virtual center that we call the Arizona Pest Management Center. I'm currently the director of that virtual center, and it helps organize all university resources in IPM. So I don't have to be an expert in plant pathology or a particular disease, soil-borne or otherwise, or a nematode or a weed. I'm an entomologist by training, and I try to stay within my expertise and work very extensively in cotton and Waiuli crops. But other people are working in tree crops or forage crops or cover crops or tree nut and
you
vine.
specialize, but you can't specialize. You have to have a community of people.
You have to have a community. There's just too much of it for any one of us to do. So we organize through the Arizona Pest Management Center. We have a 25-member stakeholder group that advises us. We make investments. We form teams of which are made up of all these disciplinary specialists, but we put them in the room together, right? They're not allowed to stay out in their silo. I have to be in a room with a plant pathologist, a weed scientist, a soil scientist, an expert educator, in order for us to understand what really are the problems. Because a grower might say, well, I have this problem, but it may be multidimensional. It may require a solution in the soil.
One solution could exasperate the problem, is what you're saying.
Certainly, yeah.
Now, how did it all work 100 years ago, 150 years ago, before this age of information and communication? Obviously, we have a much smaller population back then than we'd have now. So that's different. And the spaces are different. So space means a big thing too, because if you're on top of each other, that's where airborne illnesses or soils can, it's now we're all forced to be neighbors. So how does that work?
Well, I think you first said 100 years ago, which is going to prompt me here. And then you corrected and said 150 years ago.
Before the Industrial Revolution started.
Well, I'm gonna focus on that because I'm wearing my colors today, and I have a little emblem here that says 100 years. Well, this is now 10 years old. We're now 110 years into the development of cooperative extension. So cooperative extension was formed in 1914. So we're at a 110-year anniversary really right now. And so no, not 150 years ago, but I'll talk about 110 years ago, because even then, you said it, we were a much smaller population. We were distributed all over the state. We were more agrarian, very rural. now cooperative extension has this charge to connect these people to the science that's being generated at our land-grant college, which is the University of Arizona. And what they did back then, and even before 1914, is they used to charter a train over in Wilcox, and they would load it up with all their educational materials. There'd be a whole trailer full of animals, a whole trailer full of plants, and another trailer for 4-H related materials.
It's like the circus coming to town.
Yes, and they would take that train from Wilcox and bring it all the way over to Yuma, making stops all along the way, and people would turn out, and this is how they got some of their technical education back then.
Yeah.
So it was a different time.
Yeah, it was. Yeah, but who says you don't need government, right? I mean, this is like a perfect example of a true important government service.
Yes.
That is, if you don't have food, you don't eat, right?
People don't realize just how valuable it is and how embedded it is into our culture. They don't even think of it as a government service necessarily. They just know that they can go down to their county office and find experts in master gardening or in IPM or in 4-H, and they'll get support to their communities.
And this program it predates I can't remember the date that USDA started. Actually, that was
1860s.
Yeah,
maybe.
be around the same.
Yeah.
I think it was Civil War, and they the first thing they did was the politicians created seed banks and then gave seed out to their friends. That was a form of getting things done, I guess, back then, if I remember right. But So tell me about, so we have this progression, right? And you hear people, no matter what, you hear people grouse about this, that, or the other. I talk, for instance, to a lot of scientists, so seed or soil scientists, and they say, and I got to say, a lot of them are older than me. They're retired but still living in the life. They have the golden keys to the university and stuff, and because they're passionate about it and because they're knowledgeable about it and they know how important, but they complain that there's not enough people following them. And because the science has changed that, or perhaps old knowledge is being dismissed as not being needed to some degree. So how do you see that?
Well, I'm not as old as I look. Maybe I'm pretty gray, but I'm very old school on that. I mean, I really believe in the direct observation of our systems. So you can say that people don't think much of that kind of science. Well, it's having a bit of a comeback as people are discovering their home gardens and they're seeing things and they're wanting to understand it better.
Yeah.
A guy who works on the bench all day, a scientist who works at a bench all the day, looking at genes or using machines to support them in that way, is not as familiar with whole organism biology, and even a step up from that, the multi-organism ecology that goes on out there. There's really, I think, a bit of a renaissance in interest in that.
In understanding the whole thing,
we need the integrators of this of our sciences.
The naturalists like Charles Darwin.
Absolutely, those were brilliant people.
Look back and say,
And I think, but what you've said is true. We are not recruiting enough people to replace the functions that I occupy and others occupy, which is really the convergence, as they say, where the rubber meets the road as far as science as it supports society. We don't have enough people at that interface that are knowledgeable, technically knowledgeable, but also are able to talk to and educate growers and consumers and other stakeholders about how to grow their food.
Yeah, because you talk about, and you're probably not as old as me, but you talk about, when we grew up, right, we had a garden outside. I did not have a cell phone. No. If there was a TV, it was black and white, and it was 3 channels, and it went off the air at 8 o'clock at night or whatever. So it really was a different world where you got to go outside and get beat up by your neighbors or play in the garden or whatever. Right. And so, but today it's more of a virtual world. And, that being said, we don't have as many kids going into science, technology, and math as there are job openings, even in Arizona, to a degree.
I could be training 10, 20, or 50 times more students than I currently do, and I still wouldn't be able to fill the the needs there are in the job market today.
It's crazy.
Yeah.
And instead, maybe the path, they're just not understanding these paths. That's why with UFE, we are committed to these STEM gardens. These we call them STEAM gardens, but the idea is to bring kids. Bill Gates wanted a device in front of every kid. I want them to put that device away and go back outside, and there should be a garden in every school, and it should be tied into curriculum and that kind of thing, just as a turn on, just to develop, for them to naturally have curiosity. Because I think once you're curious, like you were as a kid, you follow your curiosity and your passion, and things worked out pretty well.
Right.
So, okay, I'm going to shift. I'm going to pivot completely.
All right.
We got a tire in front of us, and we got a couple of plants.
We do.
And we've talked about guayuli before. This is a tire from Bridgestone, right?
Right.
And they're kind of the pioneers right now in the research and development of this plant, which, we've had a podcast before where we've talked about how much importance there is in plants like this for national security, and for just finding environmentally friendly plants that can be grown, right? So this was signed by the Secretary of
Agriculture.
Department of Agriculture. And this was signed by the governor. So it looks like they understand the program. That's pretty big right there. They have the Secretary of Agriculture understand what's going on and the importance of certain plants. And we talk about hemp being what we consider very important, because it's a multi-use. It's easier to grow than maybe cotton, or it grows great in rotation with cotton. It can save the cotton industry. It can be used. It can remediate the soil like this plant can. And we talked in depth about how many benefits there were in the plant itself. But let's go to the plants and the bugs that might. So this probably has less predators and less I mean, you said cotton has 800, different organisms working there, and most of them harmonious and good for the environment. This seems to me like there'd be less, but what doesn't this like? What is out there that could get your crop?
Yeah, so anytime you're developing a new crop, there's always excitement about the crop itself, the potential markets that are out there for it, and there are many.
10 years later, you find, uh-oh.
And then
it's just like every other plant, right?
Sometimes it's an afterthought. Oh, we need a pest management program, or what can we spray on this thing to protect this crop? So I think what's really important here is Bridgestone recognized the issue very early on. So they engaged myself and other experts in the pest management disciplines. So we're working on weed, disease, and insect management programs. Now, the nice thing about Waiuli, and I'm sure you learned this in your other broadcasts, it's a native plant. It's native to the Chihuahuan Desert. That's a desert that's not too far from here. They're very desert adapted. As a result, we find when we're cultivating native, I'll call it a native plant, they typically have fewer problems because that evolutionary race has already played out over millions of years.
Yeah, that's a good way.
And you now have a plant that grows in this environment with the arthropods and other things that are here. That said, however, when we direct seed these Waiuli plants, we end up with a tiny little seedling that's slow growing and is not terribly competitive with weeds or any insects that might attack it. And we have some insects that are, they're not Waiuli specialists. They pretty much eat any seedling that's out there, but they particularly like Waiuli, but they also like broccoli and cabbage and many of our brassicas. Right. And it's this one here. It's this pale striped flea beetle. For those that can view this, it's
the size of a pencil eraser.
Yeah.
Here. So it's smaller than that.
That's on a cotton cotyledon. Down here is the size of a Waiuli cotyledon, which is very tiny, smaller than a pencil eraser. And because of that, if that beetle were on top of, well, there's one next to a Waiuli seeding there. They're about as big as a cotyledon leaf. And it only takes them a matter of minutes to consume that
Then it's
cotyledon
over.
leaf.
That
Well,
plant's
you think
over for a
about
while.
any plant that has a cotyledon, that's its protein source for
That's
its
the
initial
start.
growth.
Yeah, that's
You
the
take
start.
that out,
Game
it's
over.
almost over with.
Yeah.
Yeah. So
So early on is when this does the damage.
it is. We really think, and I've been watching Waiuli grow for more than 25 years, on and off. I've been engaged with the plant, and I've seen many, many plantings over those years, and I've never seen an insect molest this plant once it's established. Once you're out maybe 60 days into what might be an 8-year growing cycle, there really haven't been any insect
It
problems.
seems like that with a lot of plants out there. That once it
That are
gets
well adapted to
established,
the
yeah,
environment.
it's adapted, right? So,
Yeah.
so how do you combat? How do you combat this early on? So this is one of the issues, is just getting the plant started.
Yep.
And it's not a super fast growing plant, right?
No, not initially.
It takes at least a couple years before you can even harvest or use it, right?
Yes, 2 years of growth, and then you can harvest.
Right.
Yeah.
So, but to get it up to a point where you'd consider it mature, this is very mature here, but how long would this be?
Those might be a year old.
Okay.
Those plants.
So
could be.
for how long does this bug really does the damage? Because this is the beginning.
I honestly think if we can get it
6 weeks, maybe?
well, I think if we can even get it 2 weeks protection,
That
3
big.
weeks protection, by then, if weather is good, you will have true leaves forming, and now you have a new protein source, right? New way for that plant to capture sunlight and manufacture carbohydrates and protein and support the plant.
Right.
So
When it converts over from
yeah.
seed energy to photosynthesis, I guess, right?
So I think it could be as little as 2 or 3 weeks, certainly 6 weeks, and you've got a plant that's pretty free and clear
Can hold
of,
us up.
of
And that's your
pressure.
major predator at this point to plant.
Major
plant.
pest. Yeah.
Pest, right.
Yeah.
So
Yeah.
I got another question, though. You grow it for 2 years. You cut it off. It's a cut and come again. And you harvest and use the plant, and you create your rubber tires and everything, right? So how hard is it then to take, and how do you, what time of the year? It could be done any time of the year where you're trying to regrow the plant. And now when it's regrowing, it's not really growing from seed anymore.
No.
So does that bug still interfere, or is not really?
We haven't seen that be a problem yet. We're going to learn more. I'm always open to learning. But now you have an incredible storehouse of energy, and that's in the form of the roots, the living roots that are in the soil.
Right.
So important to remediating the soil and supporting soil health in general. But now you have this massive roots that are supporting the regrowth.
So you got lots of leaves, even though they might be tender coming on.
I don't think there'll be any real problem.
That's a big smorgasbord for that
Yeah.
bug to. Have you seen? Is there a way to determine the infestation, the severity or the quantity of bugs that might come and hit a crop or a field, and how often do they reproduce? What's the
Both
race?
great questions. There's not a lot we don't know about the immatures of this flea beetle. They're soil dwelling, but we don't know a lot about them. I haven't seen them. We don't have a rearing process for them. They certainly go through multiple generations a year. I forget the first part of your question, but it's a perennial pest. It's always going to be out there. It's native, okay? It's here. It molests lots of crop pests that are emerging as seedlings. The difference here is Waiuli's a little bit slower growing when it gets started, and it's such a small cotyledon.
Right. So with that food source early on, would that aid in the reproduction? Would they
Yes.
increase their flock, so to speak?
Yep.
And then
More than likely, they're getting their energy, and then they're laying eggs in the soil and continuing the development of their life cycle.
But what is that life cycle from a standpoint? It's more than 6 weeks. It's before they become
Sadly, we really don't know on this
Okay.
species. Isn't that amazing? So while we're splitting genes and inserting
can't
genetic
use
content into
Basic
cells,
observation, right?
we don't have some of the basic biology worked out on these things, which is really
Interesting.
extraordinary.
Yeah, because
Yeah,
it'd
but I
be
would guess, if I had to guess, I'm going to say, and it would be a guess, it's probably got something on the order of about a month to 2 month life cycle.
okay.
So
So
there's
if you're
reproduction going on.
if you're capable of growing that crop that first month or so, and you get it up to the point where it's not just in that
Cotyledonary stage.
yeah, there we
that's
go.
A tough one.
So if you can get past that, even though there's going to be a lot more bugs being hatched, right? A lot more of these that are out there, they're not going to have the food source unless they're eating.
Well, even if
other
they're
things,
even
right?
if they're grazing on the leaves are not the major byproduct of this. Plus, they're not intense defoliators in general. So,
Okay.
a little bit of grazing on the leaves is not going to harm this plant. This is an amazingly resilient plant. We haven't touched on it yet, but it actually has its own insecticidal properties as well in its constituents.
Okay.
This is, it doesn't just produce rubber or even liquid latex for rubber applications. It produces a lot of secondary plant compounds. Again, after millions of years of this arms race, it has its own defenses, including insecticidal
Protect itself,
compounds
yeah.
that protect
All
it.
organisms fight to survive, right?
Yeah.
So in this, we don't know its natural predator, but it's in that food web as well, right? So
Yes,
there's
certainly. Yep, there are things that'll eat it. Unfortunately, their movement into Waiuli fields can be quite rapid. If you're planting in the spring, right about now, and you're in otherwise area that's been cultivated kind of clean and there's no other host plants, these things, as we heat up going into May and June, all those herbaceous plants dry down and these things have to go somewhere to feed. And if your planting timing is not right, you'll end up with a lot of them in your
So what
Waiuli
is
field.
that? When you're doing Waiuli, you can plant it. It's a native.
Yeah.
Pretty much plant year round, but
In theory.
sometimes, the heat in Arizona is prohibitive to any organism. I
That's
don't care what
correct.
anybody says, right?
Yep.
It makes things tough in the midsummer, but at the same time, if you're planting in springtime when everything's alive, including these, and they're able to come into your field, what would be the optimal time to plant?
We're still trying to uncover the answer to that question specifically. What we do know is as far as the plant requirements go, soil temperatures and soil conditions are probably best in April and maybe through or up to mid-May. And
For the planting.
For the plant. What we don't know is are there opportunities here to predict when this flea beetle is going to be more or less abundant? We talk about hot years or dry years or wet
Sure,
years.
sure.
Well, we have buggy years too, or we have years that are
Which are probably based on dry years and wet years.
in part, yes.
and
So
everything, too.
we would like to develop predictive systems so that a grower can actually know, am I planting into a window where I need to be really ready for this, or am I just going to get some incidental grazing? I think there's great opportunity there, and we need more people looking into that question.
Yeah. So there's 300 acres of this. I'm sure there's acreages all over because you guys in the Extension Service have a program where you're promoting farmers to play with the seed, right?
Yep.
And you're looking kind of at farms, maybe 20 acres at a whack. So because you're looking to do it in as many places, it's kind of
Right.
a live experiment, so to speak,
Yep.
right? Yeah, and you want to see different conditions, different farming techniques, and different results.
Yep.
So that's part of the issue. But how much of your time are you dedicated toward like Waiuli? Is that where you are full time now, or are you still? It sounded like you're the director of digital communication and everything else. So, how do you do that?
Well, I spent a great deal amount of time in Waiuli. I still work in cotton.
I still don't say that word right.
Yeah, Waiuli.
I call it Waiuli.
Why Waiuli?
It's Waiuli, yeah. Okay.
I do still work in cotton. It's still an important crop here in Arizona. And I think there's a relationship between the two crops that can be exploited, which I can say more about. I'm still investing a great deal of time. The Pest Management Center, luckily we have a lot of professionals. We have a lot of support staff, and it can run itself. People know what they need to do. So these are the principal activities I'm working on currently. And there's an interesting relationship between cotton and Waiuli. We did a study a little more than a decade ago now. We didn't have Waiuli across the landscape, but we had plantings, sort of like you just described. We had plantings here and there around central Arizona, and we did a study of the landscape around them, out 3 kilometers, roughly 2 miles radius around them, and we examined the specific concentrations of different crops, and then which ones were influential on the pest distributions. And what we found out is the principal pest of cotton today is Lygus hesperus that you tried to say earlier on.
I'll try it again.
We call it the Lygus bug. It's a plant bug that sucks on the fruiting forms of cotton and reduces the amount of cotton that can be produced. It's the number one yield limiting pest of cotton today. Well, what we discovered in that study is if you plant Waiuli into the environment, now the Lygus, it's almost like they're diverted. They go to the Waiuli instead, in part because of these lovely flowers are on here. These are flower-feeding insects. They go to the Waiuli, they graze in the Waiuli, but they don't damage it. And by spending their time in Waiuli, they're not spending their time in cotton during the summertime.
Would it reduce the yield of seed though if it went?
That's a project yet to be done. It's something we'll be looking at because seed viability is going to be important as this industry grows. And other insects. But for the moment, what we know is it's what we call an insensitive sink, meaning Waiuli can mop up Lygus in the environment and keep them from going into the cotton. So here's another example.
A lot of it's timing too, right? It's a specific time that cotton is maturing that you want to pull the bugs away.
Yes, well, 2 of the major flowering plants that are in midsummer before the monsoons come on really good and green us up later on are going to be Waiuli and cotton.
Cotton at the same time, yeah.
So these Lygus bugs need to live like anything else, so they're going to spend time where they like, and apparently they prefer to spend their time in Waiuli where they don't do damage and less time in cotton as a result.
So a cotton farmer putting in maybe rows of Waiuli,
or a field or two,
off to the side or to the perimeter or whatever it may be, or right down the middle.
We found the effects go out as far as about a kilometer away. So if you have a Waiuli field within a kilometer of your cotton field, you're going to enjoy some additional protection against Lygus because they're going to be spending more time in the Waiuli.
So it's similar. We are working in hemp with the Soil Seed and Water, the company that I have, and it's that when you're doing hemp, there's a lot of different ways to do it. And what we've found is that growing the seed separate from when you grow the biomass is effective from a harvesting standpoint, because if you're growing the seed when you don't have as much daylight,
right,
the plant doesn't get that high. It flowers and it goes to seed quicker. And because of that, you can harvest it when it's shorter. Whereas the biomass, it's got to go through, and it's got to be at the right, time of the year where it's getting 12 hours, and so it's a very tight window. You can almost set the clock on the day that it starts to flower when the biomass is ready. So that would be my my question there is, how does that relate to like a Waiuli plant as well? How would you would you maybe take some plants and grow them in the field with cotton but not worry about the seed production, and then find another location where you just grew these for seed?
Yeah, I think those are next level questions, and we're not quite ready to get there. For now, we can get both our rubber and our seed from the same crop. And I don't see right now a necessity of having sort of dedicated seed production areas. Even in cotton, we have contracted acres for planted seed because a grower might grow his crop differently to produce the seed than he does just for the fiber. I don't know if we're going to head that way with Waiuli yet. I think there's still a lot to learn about these insect-plant interactions, and especially the seed interactions. But you can see it; it's a prolific flowerer.
It's beautiful.
And that's food. That's food not only for these potential pests that we might be diverting away from cotton, but they're also food to two other groups that we're really interested in studying in Waiuli. And one is the solitary bees that make a living here in the desert. We're in a megadiverse region of this planet for solitary bees. Many people at home may know the honey bee. That's a social bee that grows in hives with many individuals. Solitary bees are just that. They're solitary bees, but they're critical to the pollination services throughout the desert.
Sure.
And they're important even in crop plants. So we think the Waiuli, the combination of the Waiuli having living roots and undisturbed soils for a protracted period of time. These are normally ground-dwelling bees, so that now they have undisturbed habitat in which to make their own nests. Combined with the prolific flowering as a food source will be a boon for certain solitary bees.
Interesting. I didn't know they nested in soil like a wasp, like a
Yes,
ground wasp.
many of them are ground-dwelling, not all, but many of them are ground-dwelling, and they're everywhere in our landscape, but people just don't notice them. But they're absolutely critical to the pollination services. So that's one group we're interested in. The other is the suite of predators. These are beneficial predators that feed on other arthropods, other insect pests, are also attracted to Waiuli and grow well on Waiuli, in part because of the floral resources that are available. Many of these predators that eat other insects, you can think of them as being meat eating, right? They're eating another animal. They also make a living by getting pollen resources as well. So having a lot of flowering to grow these predators on will make them regionally more abundant to other crops.
Which is helpful for the ecosystem in total. So when you're studying, how do you pick the study? I mean, you've got a lot of different things in a lot of directions you can go in. This guy here, you're just keeping an eye on, probably not limiting the production of Waiuli. However, you never know; it could to become a problem, right? But you're really looking more at that ecosystem around the area. So you do have that one big property, 300 acres. It's kind of a good place to test and to look at. So how do you pick these studies that you do, whether or not you're doing a broad study or a narrow study? How do you do that?
Well, I think the trick for the success of any extension program is to have a suite of approaches. So you have your real near-term studies, and we screen insecticides and other control methods, direct control methods, chemical control methods for this flea beetle. But then you have more intermediate term work where we're trying to understand the system better so we can advise growers about planting patterns, rotation practices, companion cropping, other non-chemical inputs for sustaining the ecology of the system. So how we make those decisions, it depends a lot on
budget.
On the budget, certainly. We have to have funding in order to do that. And thankfully, we have a Climate Smart grant that's supporting a lot of the work that we're doing in introducing growers to this crop. And then having the opportunities. And that's where having different growers in different parts of the state growing this, in using their methods, using their environment, their soils.
They become an extension of that science as well, because they're practicing and they can say, hey, we think this is working or not or whatever.
Right.
And so have you been learning from them? Have you any specific examples of what maybe somebody who is growing on 20 acres in Yuma or up in further north has done?
Well, what we learn, unfortunately, we learn a lot from our mistakes, right? So you really see it, for instance, if they haven't followed the basic recommendations for pre-plant tillage and field selection and pre-plant herbicide practices. If you don't take care of that, these, like any crop, can be overrun by weeds. So we've learned.
And you got that short window to get these to maturity. So-
Right. So again, it's a narrow window. Once this thing closes canopy and shades out the rows, weeds are really inconsequential. So yeah, we learn those sorts of things from growers. We're learning more about irrigation and the different ways to apply water that will either limit weed growth or save water or enhance plant growth and hopefully.
And you
make them
follow root
healthier.
patterns that way to see
Yeah.
if one's better than another. Now you've got a kit of toys next to you.
Yeah.
What do you got in there? Anything
Well,
interesting?
a lot of your listeners won't be able to see these things, but we saw the picture of the flea beetle. But there's a vial with a couple flea beetles in them.
Oh, I love that. Small.
Yeah, they are small, but they're large as flea beetles go. If you
Sure,
know how
sure.
big a flea is, which not everybody
Yeah.
knows, thankfully, they're bigger than fleas. But
So this is something that kids could see with a naked eye, not a
They
naked
could.
eye. You don't need a microscope.
they move quickly, though. They hop like a flea through the fields. I know you've
Hard
gone
to
over
capture.
You've gone over Waiuli, but that's a vial of seed, and geez, I don't really know how much is in there, but I wouldn't be surprised if
That's
there
a
are
tremendous
thousands
amount.
of seeds in there.
Yeah.
Those are the raw seeds, and then I know you've covered this as well. These pink
This
seeds.
is your coating. So who does the coating? How do you do the
Coating is done by a commercial industry.
Okay.
Incotech is the company out of California that graciously works with us in research and has helped us develop that coating so that it's loaded just to the right level.
It increases the size a
up the
little bit, too,
size,
right?
allows the planter to handle it better. But then that coating, within that coating is a toxic
Insecticide.
dose of an insecticide that the plant's roots pick up, distributes to the cotyledon, so that when this fellow comes along and gets a bite out of that cotyledon, he's not going to.
So is this a natural that comes from the plant itself? A natural?
It's not a natural
insecticide or no?
insecticide. No, it's introduced in that seed, but the roots pick it up naturally and distribute it to all plant parts for a short period of time.
I see. Okay.
And by
It's that
they're pulling it
that
out of the
window,
ground.
that first 2 months
Yeah.
that's the struggle, and then
Yeah.
it becomes a pretty easy plant to.
It's actually very
work with.
effective, and it lasts long enough for most plantings to get them out of any trouble. So
Great.
that's one part of it. But then on the biological side of it, we have several kits made up here, and these are painstakingly done by our interns. They're beautiful preservations of these things. But what we have found is that there's 6 key predators, and these are them. 6 key predators, one in each
Not
file.
just a beetle.
No.
Oh, this guy's
We're not
big.
talking about pests now. We're talking about the beneficials. These are the
Oh,
beneficials,
these are your
that
beneficials.
eat our pests. And there are 6 key species that drive the cotton system. And we have found that these are generalist predators, meaning they're omnivores. They'll eat anything they can get their hands on.
Right. So it's 6-1 right now.
Yeah.
You got.
And we believe Waiuli is going
a
to be.
spider of some sort.
Yes, that's a crab spider. See how
Oh yeah.
the arms are out in front? That's a crab
Oh,
spider.
it says it right on it. I wasn't
Waiuli
cheating at the time.
is an amazing producer of crab spiders, for instance. And you may say, oh, I don't like spiders in my house. Well, that may be, but out in a cotton field or in an alfalfa field or in a Waiuli field, those crab spiders are doing nothing
Doing
but
a lot
eating
of
these
work.
pests.
Yeah.
Yeah.
That's
So
cool.
we've come up with systems in cotton for growers to count these and then make management decisions in cotton not to spray when there's enough of these 6.
So you've given them directions. They go and they'll cut a stalk down, and they literally will shake out the bugs and count them. Is that how it works?
Not exactly, but
Okay.
but close enough an analogy. They all most of our growers in the state of Arizona employ professional pest managers that we call pest control advisors. They're licensed by the state. They have educational requirements. A very professional group of individuals that know their insects, know their weeds, know their diseases, and can help growers make decisions about pest management.
They are in communication with you guys, and you guys are.
We teach
kind
them
of,
all the latest science, and then they help us multiply the message out to growers.
It's a big form of capacity building.
It's huge. They are absolutely
can't
huge
stop, right?
to
That's
this
the-
state.
that's the
Yeah,
big
we can't
part.
say enough about how important they are, but they all are armed with a 15-inch diameter sweep net. Think of a butterfly net, but a heavier canvas. And they go out into the fields and they sweep them vigorously 100 times.
They don't even know if they're catching anything at the time. They're just sweeping.
They're sweeping, and then when they're done, they count in those 100 sweeps how many of these 6 species are in there. And then we have tables that they can look up, and they can see, well, if I have this many, if I have 6 crab spiders per 100 sweeps,
It's a healthy environment.
that's a very healthy
And if what happens if it doesn't?
Well, if he's going through and he's finding none of these, then he knows that he's on track for a pest outbreak. And usually whiteflies are the beneficiaries. Whiteflies are pests of many crops, including in our gardens, and they are pests of cotton as well.
And so there's an insecticide that needs to be employed to handle
At that point, an insecticide would be used, and we actually recommend that they use what we call a selective insecticide.
Yeah.
So,
Isn't it cool how science now has really, we all demonize herbicides and insecticides and things like that, but how much focus it is now, how much less is applied, and it's not just generally applied, whether or not you want to or not.
These are not broad spectrum products.
You now with the IPM know we need to spray or not need to spray, and if you need to spray, you've got
we have very strategic chemistry, and I know, again, we're on a podcast, but some people might be able to see this table and at least tell that it's like a stoplight, right? You got green, yellow, and red. This is exactly what we give to growers, and that's a list of insecticides. The green ones, guess what? Those are the good ones. Those are the selective ones. Those are the ones that when they're deployed, they're only killing the pest species, and they're not killing these guys. They're not killing the good guys.
Right.
They're that specific.
Yeah, well, they have to be, right? To keep that balance going, that natural
balance.
Yeah,
absolutely.
Yeah.
So all you're doing is you're applying that selective insecticide to just tilt the balance a little more in favor of the good guys, the biocontrol agents, and then the system runs on its own. So it's really rare for a grower to have to spray more than about one time for an entire crop season in cotton.
That's great.
Now, the yellow are partially selective, so there may be some benefits of their use in protecting, but they're harming some of our natural enemies. And the red ones, we want to try to avoid the red ones because they're broad spectrum and they're going to kill most of the pests and they're going to kill a lot of the natural enemies too.
Right. And you use those only in emergency situations.
Right.
But
so I don't think people appreciate where the science has gone on that.
Yeah.
You've alluded to it. When I grew up, there wasn't a good pesticide. Most of them were dangerous to handle. And
DDT back in the
DDT is what we learned about.
Although there's still people in parts of the world who say DDT was the only way to really kill the mosquitoes, which are creating malaria, right? Malaria. So we know it's not a great thing, and it was banned. But it's interesting to see that evolution and the fact that everything, I talk about this all the time, how everything is really going to the middle a little bit. It's a gray area now. It's not industrial.
We don't live in the black and white.
Right. It's not industrial versus organic. No. And if you fall prey to that, you're not understanding the adaptive process that is being followed. But
right.
Anyway, this was great. I do appreciate you, my guest Peter Ellsworth, and we're going to be doing more on this crop and what you guys do. We're going to try to do a podcast somewhere down in the future, and several months from now or a year from now, whatever, we're in your natural setting, so to speak, with the cameras, and love to continue with this because I think a lot of people will enjoy watching what we've talked about. So thank you for coming.
Thank you so much for giving me the opportunity to.
Even though you're all of you healthy scientists don't do a lot of drinking, but somebody will. So
yes, for sure.
Appreciate you having.
And I love the tagline: "Food sovereignty through a community of gardens."
There it is.
That's great.
It's all about community.
Yep. Thanks so much.
Thank you, Peter. Thank you for joining the Harvesting Wisdom podcast. Click subscribe and like for ongoing insightful conversations. Explore our webpage for show notes and additional resources. Visit our guests' webpage for deeper insights. Your engagement is the foundation of our journey, and until next time, keep pursuing wisdom.